right here we have a polynomial that we'd like to factor. So we're going to use a method called factoring by grouping. How do I start a problem by grouping?
Group them into two parentheses.
Okay.
So smart.
So I have two groups. First, I'm just going to look at my first group. Forget about this group and just look at my first group.
Yes.
In my coefficients, my 5 and my 10, do I have any common factors?
Yes.
5. Okay, so I'll take out a factor of 5. How about in my variables? Do I have any common?
Yes.
Two n's. So I'll take out n squared. If I take out 5n squared, what will I be left with in this term?
1n.
1n. Or I can even just
n.
write just n.
Yeah. Excuse me, may I ask you a question?
Yeah.
This is where I get confused.
The way that I like to think of it is what times what would give me 5n cubed. So if I have 5n squared, I know there had to be one more n to give me back to 5n cubed, just like when you're going back through multiplying.
Oh, now I get it. Thank you.
And then I need to say if I have 5n squared and I factor that out of 10n squared, what will I be left with?
5n?
Well, let's check.
No, 5.
5 times 5 would be 25. So 5 times, it can't be 5 times 5 because 5 times 5 would give me 25, not 10. 5 times 2, what's 5 times 2? 10. And so 5n squared times 2 is 10n squared. And of course I have my negative.
You minus this and you multiplying this or what?
No, so the exponent. For the exponent, it's like 2n squared and n combined to give me 3. But 5 times 1 gives me 5. Just like here. 5 times 2 gives me 10. But n squared will give me that n squared.
So you put now it makes sense.
And then I'm going to do the same thing with this group. Looking at just the coefficients or the numbers, what do they have in common?
3.
So I'll take out the 3.
No. They have in common a 1.
They do have in common a 1, but I want the greatest common factor. So if I took out the 1, that is a common factor,
But it's not the greatest.
but it's not the greatest.
So it's common because you could do 2 times 3 equals 6, that's why?
Yep.
And if you divide it, it's gonna give you 3, right?
Yes. So here, 3 times what will give me 3n?
3 times 1.
3 times 1 will give me 3, but 3 times what will give me 3n?
3 times 1n? Or something?
Yeah, 1n, which is just n. 1n and n, same thing. And then 3 times what would give me
2. 3 times 2.
2, but because I want negative, it'll be negative 2. And look, now,
It's the same thing on both sides.
exactly. So because I have the same factors now, I can factor that out and have n minus 2, because they both have it. What I'm left with would
Can they all
be,
be equal to 1 or something?
what do you mean?
Since they are the same, can you just equal it to 1?
No,
That'd
you're
be
not
the
getting
answer.
rid of it. You're just factoring them out of each of them. It's like the opposite. It's like you're undistributing it. And once you've factored it out, you're left with these parts, and that's how you would factor it by grouping.
I get it.
I get a little bit more.